Okay, I want to thank you both very much. Certainly, it's good to hear a little bit about this program in North America, where we really haven't had this kind of presentation before. I have a whole list of questions, and there are questions from the field. We do have some time for that. I'd certainly second what you said, Dr. Cagle, at the end about needing to participate in the Internet of Things with devices. That statement recalled to me a parallel situation which some of you may remember from the early days of wireless sensing, when all the wireless devices in the wireless sensor world did not speak Internet protocol, and it was actually only about 8 years or so after this 802.15.4 radios were standardized that they were able to speak Internet protocol, and suddenly people started thinking, well, we can use devices in the Internet of Things. I'm going to use the moderator's advantage here and take one question myself and then open it to the field. So I apologize for doing this, but I have to. I just can't resist. Michael had a statement, or echoed a statement from Namur, and I wrote it down. It said, you know, you wanted one uniformly specified physical layer for the hazardous areas. And I took also from Dr. Cagle's discussion that what you have done so far in the research in this area is to take existing Ethernet semiconductors, existing Ethernet physical layers, and try to adapt or in some way compensate them for the hazardous environment. So my question is, and this is really given Dr. Krause's requirement and really coming from Namur, how do we get to a uniformly specified physical layer when we're putting dependencies on existing semiconductors and then adapting them? How do we get to a uniformly specified physical layer, and also one that multiple vendors can implement? Because all the customers that you have, including BSF, I'm sure, require multiple vendors in order to adopt the technology. So how do we get to multiple vendors providing a uniformly specified physical layer? Could you comment on that? I might
Sure.
need to use the microphone.
No,
Here.
I'm still online, obviously.
You're still online, okay.
There's no other way but to do this in a consensus, because as I already said, we're not running proprietary networks. We need all the vendors to actually join, because larger customers require multi-vendor approaches over there. And the first step is always a special interest group, a group that basically considers this to be something of interest. And that's what the APL group was. Now, this is coming to an end now. We need to actually hand this over to a joint working group of an existing organization like the ODVA or Profibus International or a Fieldcom group. I don't know. Some of the groups that have an organizational structure for this kind of shared intellectual property, because that's the issue. We're now generating an intellectual property where we need to actually make sure everybody has to have access to this. And these organizations also know how to go down the path of international standardization, because sooner or later we have to either put it in the IEC or into the IEEE world and standardize it. That's the only way and the path forward. And we're at the very moment discussing in that special interest group what could be the right setup. And my personal preference is a joint working group between the ODVA and Profibus, so we're there to handle that.
And you have any comment on that, Dr. Krause?
I would also like to add, so we had this executive panel in the morning also where it was a lot about open systems. And also already there I expressed some concerns if these intents really go far beyond PowerPoint. To have really open systems, to have a common infrastructure, and to really give up vendor lock-in situations which in the end protect also the business models. And this common uniform layer is a very important prerequisite to have open systems in the end, to have new companies join these markets, to lower also the entrance barrier. And well, I'm lacking now the English sayings, but there it's really the question which deeds will follow the good intent.
Okay, thank you very much. Now, I would, for 12 questions, I've given my one, so I'm going to stop asking questions. And we have some ARC people out in the field. Go ahead, please identify yourself and ask your question.
Don Bartusiak from ExxonMobil. Listen, guys, thanks for a really wonderful paper, and Harry, a good introduction. So what are going to be the continuing barriers to full commercial success? We've already started this conversation. I'm still worried about device integration. Is FDI going to solve these problems? And, even if we change out physical layer, are we still going to have the challenges of replacing, configuring these intelligent devices against the hosts?
Excellent question, thank you. Yes and no. FDI is really a significant step forward in solving the issue once and forever, but it's not complete yet, because you also need mechanisms how to basically overcome the differences in versions. Because if you exchange a device in a plant 5 years after the primary installation, the likelihood that you can get the device in the same firmware version like the original one is close to zero. So you will have a change in versions in between. And how do we handle this over there? How do we make sure that over the jump of a version we still have this compatibility and still allow an easy plug and play by exchanging these things? And this has to be addressed by the user groups inside Fieldcom Group or Profibus International, and put it on top of the list that we have as vendors have to work on this. There are methodologies to do this, and as I said, FDI is a necessary and important first step, and I would say it solves 80% of the problem, but not yet 100%. But it is definitely the right way. I'm absolutely convinced about this.
Can I ask a follow-up to that, Dr. Kegel? Wouldn't the remaining 20% of the problems be handled if you could bundle the FDI package as part of the device itself? Then you're just communicating with IP back to it.
Yes, to a great deal. A bundling of a physical device and what we would call the administrational shell around it, the digital twin around it, would solve these problems if you have not physically detached both from each other, which makes it necessary to basically correlate the management of the versions over there if you put this together. But in some cases, it might be still the better case to separate both things. You see this from the printer industry. Most of the printers have the USB drivers inside, but if you plug in, the software still looks for the newest driver in the internet. Only if that's not available, it takes up the one that is installed in the device. So obviously, if you learn from this kind of industries over there, there is still a trade-off to do so.
And also from the approach, you need to kind of make clear what is the core, what is hardly specified, and what's very vendor independent. So this is also true for engineering systems, and what are all the add-ons. So that exchanging the device, you can make it work with a basic set of parameters and not need all the 5,000 parameters, of which some may be either vendor specific or then firmware specific, so that you have a well-defined core which is agreed on in working groups.
Okay, I promise I will not ask one more question. Go ahead, please.
Yes, I am Jose Rivera with the Control System Integrators Association. I have one question for Dr. Kegel. Ethernet IP has been around, the concept has been around for quite a while. There were a lot of limitations in terms of power, in terms of the power of the devices, but also of the hazardous environment. So I know that you talked about the possibility of going to 100 megabits per second, great, but even at the level of 10 megabits per second, it's available now. So what has happened? I mean, where is it that suddenly Ethernet IP became available, and did we just waste the time going with the foundation and the Profibus PA Profibuses?
That's a nasty question because it hits me right in the heart. But it's essentially true. We did an intermediate step, and it took us much too long to derive the necessary mature structure of our products over there. So when we introduced Fieldbus, that's 15 years ago. And it still looks like we are the absolute beginners because our end customers still complain about very fundamental issues over there. So obviously it is much more difficult to introduce these kind of technologies in the kind of process industries like it is compared to commercial markets over there. We obviously underestimated this, and now all of a sudden we are passed by a technology that comes from different sources over there, which is eventually making Profibus PA and Fieldbus Foundation far faster obsolete than we originally thought. Our thought was, well, we have maybe a parallel existence of this kind of networking for quite some years. In the demonstrator that we have shown at the Hannover Fair, the field switch that switched to the different spurs in the devices was even capable to run a Profibus PA device. So you have a migration path forward that you can combine existing Profibus PA devices in the plant with new ones running on that IP layer over there. But it's really, in essence, the truth is the standard technology coming from commercial areas passed us over, and we're now basically are able to utilize things that we haven't been able to utilize 10 years ago.
Okay, thank you. There's another question here from Joe.
Hi, Joe Kahn, Rockwell Automation, and very good job, guys. This was great. Michael, question to you. Dr. Cagle talked about the speed issue, the trade-off at the high speed and what that challenge is. How do you, BASF, see the value of higher speeds in this technology, and what would be a key application where faster would be better?
Yeah, so the direction you're going is right. So for most applications, if you're looking at single devices, speed is not too much of an issue. So if you're looking at condition monitoring and extracting those out, so the two use cases I would see for higher bandwidths is on the one hand, if you want to do a massive polling of your whole installation. So simply, if you do not want to plan your action before, but you want to extract the status of the devices instantly. So this will cause a high network load, and with current technologies, it's not simply done by grabbing a cup of coffee, so this will take some time longer. Also, if you're doing, for example, massive downloads, and this would give you the possibility to transfer data for which you would now need other communication channels, be it video, thermographic data, vibrational data. So there you would typically use different communication technologies, but if you had the high bandwidth available on a uniform layer, you could also use this to pass through these kinds of information. And also, this is a different topic, but for new kinds of sensors, I also see large use cases coming up in the future for plant surveillance with novel technologies. And those will have a certain bandwidth requirement.
Okay, next question is from Paul.
I'll introduce myself. I'm Paul Sirico. I'm the head of marketing for the FieldComm group. Harry, you parenthetically described FF and HART by their rather slow and old physical layers.
Sorry.
Which is
Yes,
fine, that's
did.
fine. But in fact, the application layers for both of those protocols, the command functions and the function command set in HART and the function block model in FF have been developed and refined for over 20 years, and they're used throughout the industry in a variety of different ways. So, how does the APL address those physical layers, and how do you the application layer, and how do you prognosticate what will ultimately happen there?
Well, it's a good question. The nice thing about IP communication is you can basically talk about the physical layer first and then say, well, we are linking into a data link, and what comes on top is a different question later on. My very first thought was always to see the advanced physical layer as an improvement of the physical layer of Fieldbus Foundation, because all the function block models were though appropriately defined over there, or even hard over IP is a nice add-on if you just want to basically look at the parameters rather than on the measurement value over there. That highly depends on the vendors and end users' recommendations and requirements over there. I think there is a large variety on protocols that we can implement over there, be it Ethernet IP or Profinet or the function block modeling of FF. And it's a question of requirements, a question of what the end user finally has to say to this over there. Again, the existing physical layer is not a bad physical layer. It is actually the best that we ever had. It is ultimately robust, and it allows a very nice installation. Unfortunately, the extra in installing it and the extra in educating your people is not really compensated by the benefits you're getting over there. That is something we're working hard to convince people that actually there is a benefit even with digital communication of today. And most of the plants that tried it out come to the same conclusion. Yes, there is a benefit, but is it really worthwhile the extra efforts I have to go to? It's still the equation is not clear. It's not that you can say, well, by 100% it overweighs the introductional hurdles over there. Sometimes it's a tie. And then you really can say, well, is it necessary? Is it feasible to do so, like Michael said over there? So, and when you have invested a lot into physical layer components of the FF technology of today, it's a pity to see that the adoption rate is so slow. But what will you do? Finally, your customers pay you for the benefit and not for some sexy products. Yeah.
Okay, another question here.
So I understand, you know, the advantage and disadvantage of going with Ethernet. And as soon as we started with Ethernet, and especially on the Profinet device and things like that, the two things that popped up, you know, the IT department comes back in and say, hey, how many ports you need on Ethernet? So now we are coming up with the, you know, switches and things like that. And usually the IT manager and OT usually don't have that kind of a management layer, if you think about on switches and things. And the second part that popping up is like, the IP addressing, right? So if you look at the number of devices on the Profinet and the Ethernet, I mean, now they are like request, you know, before it might have just a one entry because of the gateway. Now they are asking for like 500 devices, IP address and all that. And suddenly this whole thing just coming up so fast in a way. Is there any symmetrical method that we should be prepare ourselves with that?
That's a good question. First of all, the number of addresses since we have IPv6 is not limited anymore. So we can't basically build up devices enough to basically carry that over there. So addresses are available. That's not the issue anymore. It was at the beginning. Now it isn't. Second, are there methodologies to really have semantics or stuff like this to make this kind of networks communicating more easily and reducing the engineering time? Yes, there are. The internet works like this with relatively simple semantics, and the automation people have done a lot of, let's say, preparatory work on this. We have OPC-UA, which is a universal architecture that allows, with a certain modeling also, to build something like a semantic and what we would call an ontology. Underneath, we have standards like E-class or automation ML, where we have all the necessary ingredients that you need to build up an entire administrational shell for the devices, that you can actually plug them in and they start to communicate and organize the communication and the networking among themselves over there. But it's still some more way to go. Most people talk about this without having a look into the in-depth issues over there, and there are still issues. It's still on the level of the universities at the very moment, but there are maybe hundreds of examples how nicely these things would fit into each other, and we did a lot of preparational work over there. The E-class standard, which is something like a dictionary for automation equipment, basically consists of 50,000 different parameters that we use to describe products in a non-vendor specific way over there. We worked 5 years on that standard to collect all these 50,000 things. Now we have a dictionary, and we have to utilize this in building up these, today we call this ontologies, so the mixture of semantics, of syntax, and of dictionary to really have a seamless build-up of a network communication over there. But it's still some more months and years to go down the road, but there's a path that you can see, and it's easy to basically copy this from the standard internet over there and understand their mechanisms and do the same in automation.
Comments?
Yeah. So from a demand side, yeah, IPv6 is a clear must, and I don't know the in-depth issues of that, but I think this might be quite prototypically for end users is that we would expect from the process automation, if you talk about Ethernet and IP, the same as we have from our IT environment and from the internet. So first of all, in the first approximation, we would simply expect it to work. Yeah.
Okay, we have another question over here, please.
just like you're going down the path of the evolution of Ethernet and IP in industrial, I didn't hear anything about the evolution of wireless into the same IP structure. 802.11, AH is coming out this year. It's low power. Other 802.11 capabilities. I heard wireless HART. Is wireless just a niche? Maybe it's a bridge, a temporary bridge, or a niche for certain use cases, but or is there a possibility for it to become much more common as some of the more IP-centric wireless evolves?
So for many devices, I would see it as an intermediate bridging the gap. So if you have devices and you want to equip them now with additional sensors and with cyber communication capabilities with a high bandwidth. So there I would see it as an intermediate step. But I also see for these technologies like 6-low VPAN, etc., continued use cases. But this more in a sense of additional sensors for the plant, and maybe also sensors which you might place temporarily and which are not production critical. So to give this more, in the end, like this agile approach, that you have maybe also some kind of multi-sensors and you apply them at a certain part of your plant and you see which kind of information you can conclude from the data you're gathering, and then if this is not creating value, you can change the setup quickly without changing the wiring. These devices could then also be powered by batteries, and for those I see also a continued use case.
Maybe I can add from a vendor-specific viewpoint. Of course, we would love to see that this spreads as a major technology over there, but we have to also admit that the technology at the very moment is still very expensive. So if the wireless gateway is actually the same price like the device, then you have a misproportion over there. So it's also our task to work down the costs of these models, that it's actually only an incremental cost on the device rather than doubling the cost of a device if you want to turn it into a wireless device. So some more homework to do for us. I do believe that it is not just a niche character structure. We see a lot of mobile equipment. We see a lot of even parts of the plants which are basically put on a truck or something like this, and you don't like this to be hardwired to somehow. Wireless has clearly a larger field of application over there. But again, if you're not able to drive down the prices considerably, it might stay as a niche character product.
Okay, we have time for one more question. If there's one more person brave enough to hold their hand, I have one over here.
Thank you. I guess I'd just be interested to hear your comments about the choice of Ethernet for the physical layer. I mean, Ethernet by nature, non-deterministic, variable latency. For some applications that may not matter as much, but for broad scale use in instrumentation, that would be an issue, I would think. And as well, you mentioned the cost, but I mean, you're going to have to power the instruments through Ethernet cable as well. The cost of doing that on a per unit basis is still somewhat expensive. I'm just curious to hear your thoughts in those areas.
First of all, you're absolutely right. Latency time is an issue in these kind of networks, but in the applications of the chemical and process industries, you're not talking about latency time requirements of a millisecond or something like this, like in the high-speed industries, when you basically want to synchronize frequency converters or stuff like this, you're easily down in what we call isosynchronicity of maybe 100 microseconds or less over there. Forget Ethernet technologies for the next 5 years in this regard. So over there, it's not doable over there. Here in the process world, the process dynamics are not that you require more than a measurement signal every 100 milliseconds. In some rare cases, maybe every 10 milliseconds, but honestly speaking, I don't know a single application where this would be required over there, but Michael can definitely kick on this. Second, the question of power. It is definitely true that combining power and communication on two lines adds some costs over there, but it is by far less expensive compared to two different engineered solutions into the hazardous area for energy and for information, because handling an energy or information pass into a zone 1 area, for example, is extremely costly, and therefore our customers would like to avoid this wherever possible. Wherever they can combine this and have only one entrance into the hazardous area, they would do so, even if that adds some cost to the device.
Yeah, of course. So the typical cycle times of the DCS, so reading, processing, writing are, if it's fast, 500 milliseconds, if it's slower, 1 second. So for the absolute majority of the applications, so this is enough. I think there are also technologies to make it feasible if you need higher reliability, so with timestamps along with the signals to make this more transparent in the end. And you also touched a question, so where I'm not fully decided actually. So this is the determinism versus a high bandwidth. So how high does a bandwidth need to be that you can, with good feeling, have no determinism on the network? You could still work with something like a reserve bandwidth, etc. But I think also there the acceptance will grow that high bandwidth can replace deterministic approaches.
Okay, we have run out of time. I'd like to thank our panelists, Dr. Kegel and Dr. Kraus, for coming over here and giving this very stimulating, thought-provoking presentation, especially when they were both, I think, a bit jet-lagged from the trip, which we could not tell. So thank them very much.